Okay, let's continue with set theory. And we're looking at more of the things that you need to understand as we progress. So, starting things off, we'll try to look at what we are calling a subset. Okay, so what is a subset? A subset is basically just a set within another set. And for example, we can look at this. This is a Venn diagram, and we have, so this is set A. And inside set A, we find that we have another set, which is set B. In this case, we can say that set B is a subset of A, and the symbol for a subset is this. That's a symbol for a proper subset. And again, there's this other one. Then there's this. This one means not a subset. This is a proper subset. Okay. So this example that I've given you is what we're calling a proper subset, and we can denote it like this. B is a subset of A. That's meaning that B is inside A. Okay, what about this case? Where do you use this case? There is an interesting scenario that occurs where we find that set A is also equal to set B. So if set A is equal to set B, it simply means that set B is equal to set A. Okay? And it also means that set A is a subset of B, and set B is also a subset of set A. How do you represent this scenario in a Venn diagram? Yeah. Let's try to write this. So this is our set. It's set A, but again, it's set B. You see? So the same things that are in set A, they are also the things that are in set B, making these two sets equal. So we can think of it to say set A is inside set B, and again set B is inside set A. A little bit confusing, but that's what it means. Okay, so to represent this scenario that I've written here, we can use this symbol. Instead of writing these two like this, we can just say set A is a subset of B, meaning that if we use this one, it means that set A is a subset of B, but again set A is equal to set B. Or we can write it like this as well. Like this as well. Okay, so that's what you need to know about this case. Then the third case where we use not a subset is where maybe, for example, we have this scenario. This is set A and this is set B. We can clearly see in this case that A is not in B is not inside A, and again A is not inside B. So in this case we can say A is not a subset of B, and again B is not a subset of A. Even if we put it in this common scenario that get, even in this case it's still the same thing. A is not a subset of B, and B is also not a subset of A, right? So that's what you need to know about a subset. Moving on, the other thing that you need to understand is what we're calling an empty set. So what's an empty set? An empty set is simply a set without any elements, and it is denoted by the letter phi. Chizungwicho. Okay, it's denoted by the letter phi, or two curly braces like this. So this symbolizes, these two symbolize an empty set. So an empty set is just basically a set without any elements inside it. So representing this using a diagram. Mm, okay, this is A. Now A is supposed to have elements, maybe for example like this. But we find that A doesn't have anything. In this case, if it doesn't have anything, we can think of it to be an empty set. Or maybe it's not like this. Let me give you a different scenario. So we have A, another set. So this is set A, set B, and set C. Okay. So we find that these have some elements, but we find that there is a portion where there is no there are no elements being shared. We can think of that portion to be an empty set. Okay, so basically an empty set is a set without any elements. But it gets more interesting about an empty set. We find that an empty set is a subset of all sets. So inside every set, there is an empty set. It sounds a little bit confusing, but let me bring you to the earth. Let's say we had set A, and set A has two elements, 1 and 2. Okay. What are the subsets of set A? The subsets of set A are a set that is just having 1, and there's another set that is having 2, and there's the set that is having 1. Okay, no, let's not include this. Okay, these are the subsets of A. But if we remove these subsets, say we were to remove 1 and 2, we'll find that we'll remain with an empty set. So this empty set as well, it is a subset of what? It is a subset of A. You understand? So in every set, there's an empty set. So an empty set is a subset of every set. Okay, sounds a little bit confusing, but I know you understand from the example that I just gave. If we remove all the elements inside the given set, we'll remain with we'll remain with an empty set. Okay, moving on. What's the other thing that you need to understand after you understand this? Okay, you need to understand what we're calling a complement. Say A complement, B complement, C complement. Or we can even have A, maybe A union B, then there's a complement. What does the complement mean? The complement just simply means you list the elements that are not in that given set. So if let's say set A, we will list the elements that are not in set A. Going back to our examples using the Venn diagram, say we had two sets. Set A and set B, and they tell us to find A complement. A complement are just all the elements that are not in set A. So this part is A complement. And in other terms, you might find that you can write A complement to be equal to the universal set minus A. So you just remove A from all the elements that are in the universal set. So let's say, for example, if the universal set had elements 1, 2, 3, A just as one element, which is 1, and to tell you to find A complement, you just remove the element that is in A from the universal set. Hence, we are going to remain with 2 and 3. Okay, that's all about the complements. There is this scenario. We are going to look at this scenario as we progress, not as I'm doing this introduction. As we progress, we'll find where we can use this scenario. All right. The other thing that you have to understand is, let's say you had a scenario like A. Is it like this? Okay, no, supposed to be this, which is the same as A minus B. What does this mean? Okay, what this simply means is that you remove every element that is in that is in A, which is also part of B. So looking at an example, let's say A has the elements 2, 3, 4, 5, and 6. Then B has the elements 4 and 6. And they tell you to find A minus B or A slash B. What you're going to get is simply this. You're going to get 2 comma 3. You're not going to include 4 because we are subtracting it from this set. So we're going to get 2, 3, 5. Okay, just these. We are not going to include these elements. Okay, I think I've stressed all the basic things that I would want you to understand before we go any further. Okay, the other things that I haven't talked about, like the union set and the intersection. The intersection set. I know you have an idea of this from secondary. So it's going to come up as we solve questions, but I'm not going to go over what it means because I know that you understand. Okay, with that basic knowledge, I'm going to see you in the next video.